colossal structure that has fascinated astronomers and stargazers for centuries. It's a swirling collection of stars, gas, dust, and planets. This intricate dance of celestial bodies creates a mesmerizing spectacle that is both beautiful and complex. When we look up at the night sky, we only see a small fraction of its true size and splendor. The Milky Way appears as a faint milky band stretching across the sky, hinting at the vastness that lies beyond our vision. Our galaxy is a barred spiral galaxy, shaped like a giant pinwheel with arms spiraling outwards. These arms are filled with stars, planets, and other celestial objects, all bound together by gravity. The Milky Way is home to hundreds of billions of stars, including our own sun. Each of these stars is a potential host to planetary systems, some of which may harbor life. These stars come in a variety of sizes, colors, and ages. From massive blue giants to small red dwarfs, the diversity of stars is staggering. Some are just being born, while others are nearing the end of their lives. The life cycle of stars is a continuous process, contributing to the dynamic nature of our galaxy. The Milky Way is constantly evolving, with new stars forming and old stars dying. This cycle of birth and death is driven by the complex interplay of gravity, nuclear fusion, and other cosmic forces. Between the stars, we find vast clouds of gas and dust. These interstellar clouds are the raw materials from which new stars and planets are born. These clouds, called nebulae, are the birthplaces of new stars. Within these colorful and chaotic regions, gravity pulls gas and dust together to form new stellar objects. The Milky Way is also home to a supermassive black hole at its center, a region of intense gravity that nothing, not even light, can escape. This black hole, known as Sagittarius A*, has a mass millions of times that of our Sun central region and influencing the motion of stars and gas within it. The bar itself is composed of older, redder stars, which are more evolved compared to the younger, bluer stars found in the spiral arms are rich in interstellar matter, which is the raw material for star formation, away from the more chaotic central bar and the outer edges where star formation is less intense. The spiral arms of the Milky Way are not static structures. They are constantly rotating around the galactic center, driven by the gravitational forces at play. This rotation is not uniform. Different parts of the galaxy rotate at different speeds, a phenomenon known as differential rotation. They are constantly rotating around the galactic center with the stars and gas in the arms orbiting at different speeds. This differential rotation is crucial for maintaining the spiral structure as it stretches and twists the arms, giving them their characteristic shape. This differential rotation gives the Milky Way its characteristic spiral shape. Over time, the spiral arms can become more pronounced or diffuse, depending on the distribution of mass and the gravitational interactions within the galaxy. The spiral arms are also regions of intense star formation, as the gas and dust in these arms is compressed, triggering the birth of new stars. These regions, known as stellar nurseries, are where new stars are born, often in clusters that can eventually disperse throughout the galaxy. The disk of the Milky Way is surrounded by a spherical halo of stars and globular clusters. This halo extends far beyond the visible disk and contains some of the oldest stars in the galaxy, providing a glimpse into the early history of the Milky Way. Globular clusters are dense collections of hundreds of thousands or even millions of stars that are gravitationally bound together. These clusters orbit the galactic center and are thought to be remnants of the early stages of galaxy formation. The halo also contains a significant amount of dark matter, an invisible form of matter that interacts gravitationally with normal matter. Dark matter is essential for understanding the mass and structure of the Milky Way, as it makes up a large portion of the galaxy's total mass. The Milky Way structure is a result of billions of years of evolution, shaped by gravity, star formation, and interactions with other galaxies. These interactions include mergers with smaller galaxies and the accretion of intergalactic gas, which have contributed to the growth and complexity of the Milky Way. Strong that nothing, not even light, can escape. This black hole, known as Sagittarius A*, pronounced Sagittarius A*, has a mass millions of times greater than our Sun. The galactic center is a chaotic and energetic place. Stars orbit the supermassive black hole at incredible speeds, some moving at a significant fraction of the speed of light. The intense gravity of the black hole warps and distorts space-time in its vicinity. Astronomers have been able to study the galactic center using a variety of telescopes, including radio telescopes, infrared telescopes, and X-ray telescopes. These telescopes allow us to see through the dense gas and dust that obscures our view of the galactic center in visible light. By studying the motions of stars and gas near the galactic center, astronomers have been able to determine the mass and properties of the supermassive black hole. The study of the galactic center provides insights into the extreme environments found at the hearts of galaxies, as well as the role of supermassive black holes in galaxy evolution. Section 4. Stellar nurseries and graveyards. The Milky Way is a dynamic and ever-changing galaxy, with stars being born and dying in a continuous cycle. Within the spiral arms, we find vast clouds of gas and dust, known as nebulae. These nebulae are the birthplaces of stars. One of the most famous nebulae in the Milky Way is the Orion Nebula, visible to the naked eye as a fuzzy patch in the constellation Orion. The Orion Nebula is a stellar nursery where new stars are forming from collapsing clouds of gas and dust. As the gas and dust collapse, they heat up, eventually igniting nuclear fusion in their cores and becoming stars. As stars age, they eventually exhaust their nuclear fuel and die. The way a star dies depends on its mass. Massive stars end their lives in spectacular explosions called supernovae, while less massive stars, like our Sun, will eventually shed their outer layers, forming planetary nebulae. The remnants of dead stars, such as white dwarfs, neutron stars, and black holes, are scattered throughout. Section 5. A galaxy of stars. Each star is a glowing beacon of light, a testament to the incredible processes that govern our universe. Stars are classified future behavior. The Hertzsprung-Russell diagram is a key tool in this classification, plotting stars according to their brightness and temperature. The hottest and most massive stars are blue giants, which burn brightly for a short time before exploding as supernova. These stars are incredibly luminous and can be seen from great distances. Their short lifespans, however, mean that they are relatively rare in the galaxy. At the other end of the spectrum are red dwarfs, the most common type of star in the Milky Way. These stars are much cooler and smaller than blue giants, and they burn their fuel very slowly. This slow burn allows red dwarfs to have lifespans that can stretch into the trillions of years. A yellow dwarf, a relatively average star in terms of size and temperature. It is not the largest, hottest, or most luminous star, but it is perfectly suited to support life on Earth. The Sun's stable energy output has allowed life to flourish on our planet for billions of years. It lies in the main sequence of the Hertzsprung-Russell diagram, a graph that plots the luminosity of stars against their temperature. This main sequence is where stars spend the majority of their lifetimes, steadily burning their hydrogen fuel. In addition to single stars like our Sun, the Milky Way is also home to binary stars, where two stars orbit around a common center of mass. These systems can be incredibly dynamic, with the stars influencing each other's evolution in fascinating ways. Some binary stars are so close together that they transfer material between each other, creating spectacular displays such as novae and supernovae. These interactions can lead to dramatic changes in the star's brightness, and can even result in the formation of entirely new types of celestial objects. The study of stars in the Milky Way allows us to better understand the processes of stellar evolution, the diversity of stars in the universe, and the conditions necessary for the formation of planets and life. By observing and analyzing these distant suns, we gain insights into the past, present, and future of our own solar system and the broader cosmos. Each star is a chapter in the grand story of the universe, a story that continues to unfold with each new discovery.